This is an introductory video on polynomials. We're going to start off with some terminology, and chances are, if you have already worked with properties of exponents, that you know what a monomial is. So a monomial would be something along the lines of 3x or 9y to the fifth, or even 7x squared y to the 10th. Okay, those are monomials. Binomials are when we take two monomials and we either add or subtract them together. So 4x minus 1 is a binomial. 7xy plus 2y to the third is a binomial. Negative x plus y, also a binomial. The difference between a monomial and a binomial is that there are two monomials in a binomial, which probably now allows you to figure out quickly what a trinomial is. And that's when you have three monomials together. So an example, 3x squared minus 5x plus 2. Monomial, 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 with subtraction and addition in between them. And there's a trinomial. Now you might look at that too and say, why is that a monomial? Well, there's really whatever variable you want here to the 0 power. Oops, keep the 2. Another trinomial, 5x cubed plus 3x squared y plus 120 y to the third. So just 3 terms. Now, obviously, we could continue. We could put 4 terms and 5 terms and 6 terms and 7 terms and 8 terms. And all of these things together are the polynomials. One more addition to make here, just like that 2, the number 5 is a monomial. Any number, negative 10, is a monomial. Okay, so these numbers are actually also polynomials. There's just one of them, but still. Now, let's talk about these 4 terms down here. So terms, when I say terms, these are all terms, words, but terms are how many monomials are there in your polynomials. So if you looked at each of the monomials, you have 1 term. If you look at the binomials, you have 2 terms. If you look at the trinomial, you have 3 terms. Coefficient. The coefficient of this monomial is the number in front. So I'm going to write that down. 9y to the 5th. The coefficient is just the 9. And each term will have a coefficient, whether it looks like it or not. So here's a polynomial. 7x squared minus x plus 2. We look at each term and we can determine the coefficient. So the coefficient of this term is 7. The coefficient here, even though we can't see a number there, there's a negative 1. So the coefficient for that middle term is negative 1. And this term without a variable is actually called a constant. So when there's no variable, it's just a constant, not necessarily considered a coefficient. So there's another term that I should have probably added in there. The base of this is more of a monomial term. So if we're looking at the same problem, 9y to the 5th, the base here is the y. What is being raised to the exponent? And that would be the y. The degree of that monomial is the exponent. What is the power that is being raised to? Now that gets a little bit more complicated when we start looking at something like this monomial. So 5x cubed plus 3x squared y, which is y to the 1, plus 120 y to the third. When there are multiple terms in a polynomial, in order to determine the degree, we're going to look at the degree of each term. So the degree of the first term here is 3. The degree of the second term is the sum of all of these exponents. So we have a 2 and we have a 1, so that term also has a degree of 3, and this term has a degree of 3. The degree of a polynomial is the highest of any of the terms. Now, since these are all the same, this polynomial is a third degree polynomial. Let's do a different one. 7x to the 10th y minus 9x squared y to the 13th plus 7. We're going to look at each individual term. We're going to determine the degree of each term. Okay, we have a 7x to the 10th y. We're only looking at the variables and what their total degree is. So if I add those two, this first term is 11th degree, here is 15, and here, since there's no variable, that term is degree 0, also known as a constant. So we compare those three numbers. Clearly 15 is the largest, so this is a 15th degree polynomial. Now, when is something not a polynomial? You could have addition and subtraction of multiple terms. Could be 7, could be 10, could be 1. Okay, and what we're going to watch out for are these. These are the three main issues that we're going to run into. There are others like logarithms and trigonometry, sine, cosine, tangent, things like that, that will throw a wrench in this, and there will not be polynomial. Okay, so let's look at the first one, division by a variable, okay, also known as negative exponent. So if you saw 7x to the negative 2, which is the same as 7 over x squared, okay, that variable is dividing that coefficient, even though it looks like originally it's not. So we're either looking out for a negative exponent or division by a positive exponent. Not going to be a polynomial. If this term shows up as part of a polynomial, for example, if this was 7 over x squared minus 3x plus 4, there's nothing wrong with these two components. These two terms are fine. This term, no good. So really, we can't have a negative degree for any of our terms. Rational exponents. What's a rational number? Any fraction. These are also considered square roots. You may not have learned about these yet, but if you see one, it's not a polynomial. So x to the half power, which is the same as the square root of x. Not a polynomial. Again, if you see any fraction that doesn't reduce to a whole number or an integer value in the polynomial, it's not going to be a polynomial. So, example, 5x squared minus 9x to the negative 3/8 power plus 22. 5x squared is fine. 22 is fine. Oh, here's a fraction. Not only a fraction, it's also negative. So it violates both of these rules about being a polynomial. This is no good. Now, that doesn't mean we can't work with it later on, but for now, we're not studying that type of equation. Variables in the exponent. 3x squared minus 2x plus 5 to the x. Big problem. We are not dealing with x in the exponent. Those are called exponential equations and not polynomials. Again, logarithms, trigonometry, what those look like. The log base 2 of x, or the sine of x, the cosine of x, the tangent of x. If you see any of these things, you're not dealing with a polynomial. And that's an introduction to polynomials.